Hello everyone, this is Mr. Appel, and I'm going to walk you through this example from start to finish. So first, of course, we need to graph all of the inequalities. So I'm going to start with y greater than or equal to 2. The line y equals 2, of course, is that vertical line at 2. Greater than 2 is above that line, but we're shading the opposite, so I'm going to shade below. That's the points that are not included. Now I'm going to do this little inequality. This one looks a little bit funny. You may recognize it from our last unit, which is, this is really two different inequalities in one. It's all the x values between 1 and 5. It's all the x's that are bigger than 1 and also less than 5. So you can think of it that way, or if it's helpful, you can think of it as two separate inequalities, x greater than or equal to 1, and then also x less than or equal to 5. Either way, the line x equals 1 is the vertical line at 1 on the x-axis. The points greater than that are over here to the right of it, but again, we're shading the opposite. So I'm shading over here on the left. Again, these are the points that are not in our solution set. Similarly, the graph of less than or equal to 5, x less than or equal to 5, that's a vertical line at 5 on the x-axis. Shading the opposite, not the ones that are less than 5. The less than 5 are to the left, so I'm going to shade the opposite, which is to the right. Finally, we've got the y less than or equal to x plus 3. That one's in slope-intercept form. So I've got my y-intercept at 3. My y-intercept at 3. Slope is 1, because that's a 1x, so I'm going up 1 over 1, up 1 over 1, up 1 over 1, and so on. I'm going to get a bunch of points so I can really see that line. I'm going to go ahead and graph that line. There it is. Shading, if I choose a test point, 0, 0. 0 is less than or equal to 3, which is true, which means I should be shading below the line over here on the side where 0, 0 is. But once again, we're shading the opposite, so I'm going to shade everything above. And then I'm going to look at what is left over that hasn't been shaded. I'm going to just shade this part in a little darker just to make it really clear that our feasible region is this shape right here. Actually, it looks like a sideways trapezoid, if you can picture that. I'm going to try to, let's see if I can highlight this a little bit. If you can see that this is our feasible region. Nice thing about this one is all four of those vertices look like they're going to be pretty easy to identify. They're all pretty easy to read right off of that graph. So the first one looks like 1, 2 right there. Right there at 1, 2. Then we've got another one up here. It looks like that's at 1, 4. And then over here, that looks like 5, 2. So there's 5, 2. And then the one up here looks like it's at 5. It's a little hard to read on that graph. Maybe if we just zoom in. Well, it's still a little blurry, but hopefully your graph is clearer than that. Looks like it's at 8. So that's at 5, 8. And now lastly, we're going to evaluate for the objective function. So f of 1 comma 2, again, that's kind of new notation. Building on function notation, we're going to plug in 1 for x and 2 for y. So 3 times the 1 minus 2 times the 2. So that's 3 minus 4, which is negative 1. F of 1, 4. That's 3 times the 1 minus 2 times the 4, so that's 3 minus 8, which is negative 5. F of 5, 2, which is 3 times 5 minus 2 times 2. So that's 15 minus 4, which is 11. And then f of 5, 8, x equals 5, y equals 8, so that's 15 minus 16, which is negative 1. And so our maximum value out of those four, the highest value out of those four is 11, so that would be our max. And the lowest value out of those four looks like the negative 5, so that would be our minimum. And that's all. Thanks.